Yes, hello everyone. Good morning. I hope you are fine. Now, today we are starting our next topic. We have started already, second in it, kinematics. Okay, I told you about the kinematics. There we are doing the study of only motion and with the knowing the cause of the motion and without knowing the cause of the motion. Okay, then if you know the cause of the motion, then we will call it that studies dynamics. If we don't know the cause of the motion is there but we don't know cause, then we will call it kinematics. Okay, so I told you about the kinematics, but here we are doing the study of the objects those are in motion. Okay, which term are acting in the motion? Any object which are lying in our there in our environment, then there is a two state is possible. You are here, then you are also with a two type of the state is possible. You can be at rest and you can be in motion. Okay, same thing, that objects are here, any body is there, then there also two state is possible, that can be at rest, can be in motion. Rest beta when there is no change in the position with respect to our time. Time is going on regularly forward, yes or no? So with respect to time, if there is a no change in the position, then we will call that state as your rest. If there is a change in our state of the body with respect to time, then we will call it motion. Okay, so we are starting our next topic with a motion here motion, then here motion beta, that is state in which change in the position of any object with respect to time. Okay, with respect to time, with our time, then if there is a change in the position of any object, then there we will call it motion. Okay, one main thing beta, in the given frame of reference, in last class I told you what is a frame of reference. Frame of reference means any body is moving with respect to the observer. Okay, where what is the position of the observer, then according that we will find their motion. First one, if I told you, if someone is sitting inside the bus and some are standing outside the bus, then if someone is sitting inside the bus, then observed inside the bus only, then all are at rest only. Okay, but if observer will be outside of the bus, then with respect to that observer, that motion will be there of that person. Okay, because your bus is moving, that's why observer will observe that all are in motion, and those person who are sitting inside the bus, then they will observe outside everything is running. Okay, trees are there, then they are running with you, then this one our frame of reference. Okay, so that body is in motion or not with respect to time, that is depend upon the position of the observer, that we will define in frame of the reference. Okay, so here example of motion, we can say running, jumping, swimming, like this one. Any change in the position of any object, that is motion only. If there is a not change, does not change its position with respect to time, then we will call rest. Okay, this one state is known as rest. So example, we can say sleeping, sitting, standing, then all are the state of the rest only. Now next we will do with a type of the motion, that can be having different type of the motion, because position can be changed in a different form. That's why we are dividing our motion mainly in your three part, that is translatory motion, second will be circulatory or rotational motion, and third will be periodic here oscillatory motion, vibrational also you can say. Okay, first one, translatory motion. Translatory motion, rectilinear motion, but I told you that is your two type, rectilinear and second curvilinear, yes or no? In last class we have done. Then all are dividing in your three axis, one dimension, two dimension and three dimension. If any body is moving, I told you that one dimension, two dimension and your three dimension. Then if any object is moving along only one axis, that axis can be your x, can be y, can be z, then we will call it one dimension, x, y and z, we will call it one dimension. If any body is moving along two axes xy, yz and zx, any one two axes it is moving, then we will call it two dimension. Okay, 1 and 2D can be possible on the plane. Okay, on the plane any body is moving here and there, then there can be change one dimension and two dimension. And 3D beta, that motion will be in our space. Okay, any body is in the space, flying body, flying birds, flying aeroplanes, flying kite, all are coming in here three dimension, because their three axes can be changed x, y and z. Okay, so here we are dividing beta motion in a different category. First one, our translatory motion, translation motion, momentum from one location to the another. Okay, that body is moving on the plane linearly on the plane, can be one dimension, can be two dimensional. Rectilinear motion, but a body will be moving linearly only. Okay, then we will call it rectilinear motion. And next our rotational motion, and we can call it circular motion. But there is a some change in your rotational and your circular motion and your rotation. Both are beta category of the circular only, but there is a small change between them. If their momentum of any body around an axis and that axis should be fixed, then we will call it this one our rotational motion. Okay, for example, this I am taking here, this pen is moving like this one, its one axis is fixed beta. Okay, that is circular motion. Okay, rotational motion. But out of these two motion, we will call it rotational motion only, because its one axis is remain fixed only. Clear to everyone? So if axis during the revolution of the body, if one axis will be fixed of the body, then we will call it rotational motion. If during this one completely position of the body will be changed, like this one, here body of position is changing completely, so during this one part, then we will call it circular motion. Okay, for example, windows, gate, yes or no, their gate, one axis of the gate is completely fixed. Okay, another axis is the moving, that is not taking out na gate, that we are completely putting up and down, कि gate को complete उठा के close कर रहे, complete उठा के open कर रहे, we are not doing like this. One axis of the gate always fixed. Okay, so here rotational motion always will be one axis fixed. Then second, circular motion in this only, if there is not any axis fixed, that completely body revolve. Okay, we can write there completely body circulating. Okay, here completely body circulating, then we will call it circular motion. So now next, your periodic motion and oscillatory motion. That motion repeat at a regular interval, means any body is moving here and there in our along equilibrium position, mean position, you can say. That type of the motion is known as the periodic motion. In short, we can say to and fro motion. What? To and fro motion, then we will call it oscillatory motion, periodic motion. Okay, for example, beta motion of the pendulum, here written beta pendulum. Okay, pendulum, you have seen pendulum beta having their contact point, and here is a bow. But this one our bow. Okay, like this one our fixed point, here bow is there, bow like structure that is moving like this one. Okay, so as we are starting from this one position, as we are applying force on this one point, then what happened? It will go in this direction. As you remove this force, then what happened? After some time, then it will be go back, but it will be not rest here, it will go in the another direction. ऐसे ऐसे क्या करता है, रिवॉल्व करता है from this mean position, going from here, then going in this direction, come back along this one, then it will move in another direction, moving in this one like this motion, then we will call it to and fro motion. And this motion is along continuously along this position, so this position is known as the mean position. What? mean position and your equilibrium position. Okay, mean position and equilibrium position. As we are applying force on this one, then it will be go in this one direction, then it will be reach here, and this one our maximum position of the pendulum bob, that we will call it extreme position. But extreme position. So here on this one position, height will be increased, but as its velocity becomes zero, on this position, maximum extreme position, velocity becomes zero. Remember beta, keep in mind, any body we are pulling in upward direction, then on the maximum point, maximum height, velocity becomes always zero. As velocity becomes zero, then it will be fall down again on the ground. Okay, so on this one position, velocity becomes zero, then after reach on this position, velocity zero, then it will be come back again, then it will be go on another direction, it will be go back in another direction, then here again your another extreme position, then on it velocity becomes zero, then again it will be come back on this position. As velocity will be zero, then we know that beta kinetic energy always will be zero, because your kinetic energy will be half mv square, v velocity will be zero, then kinetic energy will be zero. So on maximum position, kinetic always will be zero, but potential energy, your potential energy always will be maximum. Okay, in ninth class we have done energy and type of energy, mechanical energy, energy due to motion, that is two type, kinetic and potential. So on the maximum point, kinetic always will be zero, but our potential energy will be maximum. Then on the mean position, here will be opposite beta, on this one point velocity will be our maximum, so due to maximum velocity, kinetic energy also will be maximum, but their height is zero on this position, that's why potential will be equal to our zero only. Okay, this type of the motion, our periodic motion and oscillatory motion, means along a regular time period body is moving along the mean position, that we will call it periodic motion. And oscillatory motion, you can say vibrational motion also. Okay, body vibrating here and there like this one, and along the mean position, so this one also our type of this motion. Next beta, this one randomly motion, we can't predict the motion of the momentum. Okay, if we can predict, means we can find their type of the motion, linear motion, moving on the plane in one dimension, two dimension. Okay, that is circular motion, like this one motion. So if we can't predict the type of the motion moving here and there, we can't find. So this one type here, random motion only. For example, our gaseous particle, we can't see, we can't give the direction gas particle in one way, they are moving randomly in our environment, that's why that is random motion. These are the different type of the motion in our kinematics. Okay, then after this one beta, during the motion, then motion in a straight line, during the motion position is changing of any object, then different terms will be there. Okay, so here if a body, see here picture, a person with a cycle, then it is moving, changing the position from initial to any point, then there is some path is covered by this body, yes or no? If we are here taking a car, then this one car beta take the position. Okay, motion will be there. I told you beta, there is a maximum possibility two state, can be rest, can be in motion. If motion will be there, then what happened, which term we can read. Okay, so if motion will be there of this one, then this one in motion. Okay, if motion will be there, then position will be changed. Okay, then during the change in the position, then how its position will be changed, then how much will be changed, means how much path will be covered by this one during this one from initial to final, then during this covering path, then how much force will be acted there, what is the acceleration, how much change in the velocity, what is the velocity, that is displacement by time. Okay, then how much cover. So here from here to there, then change in the position, then during this one, that path is covered from initial to final point, initial to final point, then this one is equal to your distance and displacement. Okay, so now distance and displacement both are path covered by any object, but there is a small change between them. Beta, see here distance is measure of how much ground an object has been covered during its motion. Okay, means any body is starting from a one point, then as covering some there, path covering, then how much ground it is covered by that object, we will call it distance. But displacement is how far away from our initial point, then we will call it displacement. Okay, there is a how much this one, and this one here how far away from our initial point, then we will call it displacement. Okay, if we are starting from one point and again you are coming back on that point, घूम फिर के क्या है वापस उसी point पे आ जाते हैं, then we will call it displacement equal to 0. ओके, बट वहां घूम फिर के वापस उसी पॉइंट पे आए तो हमने क्या है कुछ ना कुछ ग्राउंड पे क्या किया, कवर किया. ओके, तो कितना हम कवर करके आए उस ग्राउंड को, उसको हम क्या बोलेंगे, डिस्प्लेसमेंट. क्लियर. और उस पॉइंट इनिशियल पॉइंट से कवर करके कितनी दूर हम गए, हाउ फार अवे फ्रॉम द इनिशियल पॉइंट, देन वी विल कॉल इट displacement. Okay, so your distance is how much covered and this one is how far away from this position, then we will call it displacement. Okay, so here distance and displacement, then total path. Okay, total path covered by any object from initial to final position, then we will call it displacement. Okay, total path covered from initial to final. For example, beta, see in this picture, here a boy is sitting on the cycle, then starting from here. Okay, then covering from A to B, then C. Clear. Then from A to B, he is going from initial A to B, then some path is covered from here to there till home. Okay, so from B to C, then some path covered by him. Okay, so here this plus this will be total displacement, total distance. Okay, total path from here to there, that is total distance. Okay, but if we are talking here about the displacement, how much displacement? Displacement is our not total path, it will be our shortest path covered from initial to final. Initial to final तक आने के लिए shortest path क्या हो सकता है, that is our displacement. Okay, so from here to there, that is not shortest path, this one our total path. So distance we can write there, here distance we can write here, distance in this picture how we can find total distance, 4 plus here 3. Okay, that will be 7 meter our total distance. Okay, so but displacement we can write, beta, displacement will be our displacement will be our shortest path. Okay, how far away from the only far we have to find out कि हम initial point से कितना दूर है. So how we can write there, A to C our shortest path. So this one distance will be our 5 meter. So displacement will be here 5 meter. Clear to everyone? And this one here only path we are covering, that's why its unit will be meter only. Path how much we are covering, that will be meter, not meter per second. We are not talking about the time कि हमें कितना टाइम लग रहा है वहां तक जाने में, ऐसा नहीं कह रहे, सिर्फ हम बात कर रहे हैं कि हम कितनी दूर जा रहे हैं. Okay, so its unit will be meter. Okay, can be its unit kilometer, can be unit their centimeter, but SI unit only will be meter only. Okay, so it is scalar quantity. We have done already in 9th class, but a scalar and vector quantity. Scalar quantity, beta, those quantity which are having only magnitude. Okay, but only magnitude, then we will call it scalar quantity. Okay, we can define only magnitude, means how much covering. Here, from here to there, total is 7 meter. Does not matter their direction. Okay, here does not, only magnitude, does not matter direction. Okay, in which direction that body is moving, then that is not matter. यहाँ पे क्या है, डायरेक्शन मैटर नहीं कर रही बेटा, किधर जा रहे हैं, किस डायरेक्शन में जा रहे हैं, सिर्फ हम क्या कर रहे हैं, डिस्टेंस पाथ वी आर फाइंडिंग, हाउ मच पाथ वी आर टेकिंग टू कवर इट. Okay, so it always will be scalar quantity. All physical quantities we are dividing beta two parts, scalar or vector. If we can define the direction with magnitude, magnitude means mathematical value. Okay, having mathematical value, mathematically. Okay, just force meter, 10 kilometer, like this one mathematically we are writing, then always we will call it scalar. And some quantities which in which we can define the mathematically value also, but as well as the direction also, then we will call it vector quantity. Okay, so its value always will be positive. If we are starting from any point, then we will cover some path, yes or no. How much path we have to find out now, then we will cover some path, then always will be positive, never be equal to negative or zero. Next, its SI unit will be beta meter only, its SI unit will be meter only. Okay, don't take here meter per second, because here we are not talking about the time. Next will be shortest path beta, shortest path covered by any object from initial to final, that we will call it displacement. Then shortest path out of initial to final, which one path is our shortest? For example, we are standing our in this one room, we are moving here and there from initial to final point. Okay, one corner initial, second is our final. Then there is a many way to go from initial to final, another one corner. But out of these all ways, only one way will be that in which we can cover the shortest path. Okay, so shortest path will be our displacement. It is our vector quantity, it is our vector quantity. We can define their direction as well as the magnitude. And next will be, it can be positive, negative or zero. And its SI unit will be our meter. Its unit also will be same as distance only beta, because its unit will be, here we are not talking about the time, both are type path only. Okay, so test path and total path. Clear to everyone? Okay, in next class beta we will do our speed and velocity. Okay, thank you.